Today looks sunny, but is it warm enough to go outside without a jacket? Let's ask Copilot. Hi, Copilot. What is the weather like today?
It's 24 degrees.
Pretty cool, right? But have you ever wondered how Copilot actually understands what I'm saying and respond in a natural human-like voice? If yes, you are in the right place. Hi, I'm Sarah Alali, a senior technical trainer at Microsoft, specializing in AI, Copilot, and building intelligent and secure applications on Microsoft Azure. I have a PhD in computer science and 12 years teaching training experience. This course covers 12 sessions, where we will dive into core AI concepts in Azure and learn how to turn ideas into real applications using modern tools like Microsoft Foundry. In session number 7, we will cover an introduction to AI speech concepts. I will walk you through the core concepts of AI speech, how applications can listen, understand, and even talk back to users. We will cover things like speech recognition and speech synthesis. We will break it down in a simple way using real examples. So let's break down what is happening behind the scene when you talk to AI. Let's get started. Now, what you just saw with Copilot isn't just a demo. It's actually the same technology used in real-world scenarios at scale. Let's take a look at a powerful example. Imagine a global customer support team handling thousands of calls every day. Customers speak in different languages. Agents need accurate notes. Managers want searchable records. And some customers need hands-free or accessible experiences. This is where speech-enabled AI solutions come in. They allow applications to listen, understand, and speak, making interactions fast, more natural, and more inclusive. At a high level, almost all speech-enabled solutions are built on two core workloads. The first workload is speech-to-text, or speech recognition. Speech-to-text converts spoken audio into written text. The audio can come from a phone call, a meeting recording, a live stream, or a microphone. For example, in our customer service center, speech-to-text can transcribe calls in real time, so agents don't need to take notes. In meetings or interviews, it can generate transcripts and captions automatically. In healthcare, professionals can dictate notes instead of typing, saving time while improving accuracy. Once a speech is converted into text, it becomes searchable, analyzable, and easy to store. The second workload is text-to-speech, or speech synthesis. Text-to-speech does the opposite. It converts written text into natural-sounding audio. This is what allows applications to talk back to users. Voice-activated assistants use it to answer questions. Customer support systems use it to read responses over the phone. Accessibility tools use it to read content out loud for users with visual or reading challenges. Text-to-speech is especially important in hands-free scenarios such as driving, mobile use, or smart devices. The most powerful speech-enabled applications combine both of these capabilities. A voice assistant listens using speech-to-text, understand the request, and responds using text-to-speech. A meeting tool captures what was said, turn it into text, and later read summaries aloud if needed. These experiences feel natural because they reflect how humans communicate, by speaking and listening. As we already said, speech recognition is how spoken audio becomes text. Imagine a company that records thousands of customer support calls every day. Agents need accurate transcripts. Managers want searchable conversation. Compliance teams need reliable record. Speech recognition is what makes all this possible. Speech recognition, also called speech to text, converts spoken audio into written text. And while it feels almost magical to users, under the hood, it follows a clear and structured pipeline. Let's walk through that pipeline at a high level. The process starts with audio capture. A microphone captures sound as an analog signal, which is then converted into a digital waveform, and the system samples the audio thousands of times per second to create a numerical representation of the sound. The quality of this step matters a lot. Background noise, microphone quality, and distance from the speaker all affects accuracy. Next comes pre-processing and featurization. Raw audio contains far too much details to analyze directly, so the system transforms the waveform into a compact set of features that capture what really matters for speech. These features represent how strong different frequencies are over time, approximating how the human ear perceives sound. This step removes unnecessary information while keeping the pattern that distinguishes speech sounds. After that, we move to acoustic modeling. Here, the model maps those audio features to phonemes, which are the smallest units of sound in a language. For example, the word cat is made up of 3 phonemes: a k sound, a short e sound, and a t sound. The acoustic model predicts which phoneme is most likely at each moment in the audio. Phonemes alone aren't enough. This is where language modeling becomes critical. Different words can sound identical. Think about 2 words that have identical sound, but the meaning depends on the context. The language model uses knowledge of grammar, vocabulary, and common word patterns to predict the most probable sequence of words. This is why language modeling is so important. It helps the system choose words that make sense together, not just words that sound right. Once the most likely words are selected, the system performs output refinement, also known as post-processing. This step improves readability by adding capitalization, punctuation, and formatting numbers correctly. The result is clean, human-readable text that application can store, search, or analyze. In the previous part, we saw how speech recognition turns audio into text. Now we will look at the opposite process, speech synthesis. Speech synthesis, also called text-to-speech, converts written text into spoken audio. You can think of it as a speech recognition in reverse. Instead of listening, the system talks. Let's walk through how that happens step by step using an everyday example. Speech synthesis begins with text. This text may come from a document, a business application, or even the output of an AI model. For example, imagine this message in a healthcare app. Your appointment with doctor is at 3 p.m. To a human, this is obvious. But a computer cannot simply read symbols like DR or 3:00 p.m. and sound natural. That's why the first step is text normalization. Text normalization converts written shortcuts into a form that can be spoken correctly. In our example, the system expands the sentence into your appointment with the doctor is at 3 p.m. Without normalization, the system may try to pronounce symbols or read numbers unnaturally, which would sound robotic and confusing. This step is essential for natural sounding speech, especially in business and medical scenarios. When the text is normalized, the system performs linguistic modeling. Here, the normalized text is mapped to phonemes, which are the smallest unit of sound in a language. This is about deciding how each word should sound, not just how it is spelled. For example, English spelling doesn't always match pronunciation, so the system must understand which sound to produce. Next comes prosody generation. Prosody controls how something is said, not just what is said. This includes pitch, rhythm, stress, and pauses. For example, the system may slightly emphasize appointment and pause naturally before the time. This is what makes speech sound expressive instead of a flat and robotic. Modern systems use context to adjust these elements so speech feels natural and easy to understand. Finally, the system generates the audio waveform. This is a digital audio signal that can be played through speakers or headphones. At this point, written text has become natural sounding speech. This pipeline powers everyday experience like voice assistant, accessibility tools, call center system, and navigational applications. It's also why text-to-speech feels so human nowadays. Now, let's do a quick exercise where we explore AI speech in a browser-based playground. You can also practice this exercise by accessing the lab steps in the link that you can see on the screen, or by visiting the AI-901 learning path through the Microsoft Learn platform. Let's go! In this exercise, we are going to explore AI speech, and we're going to interact with generative AI model using speech, and let's see how it answers. I'm going to explore the two things, speech-to-text and text-to-speech functionalities with the generative AI model. For that, we are going to access our chat playground in aka.ms/chat-playground. You can also practice the same exercise by accessing the exercise in the learning path for AI-901 course. And as we said previously in other sessions, you need the specific hardware and also software in your computer to be able to do this exercise. First of all, you need to have a modern browser, preferably to have a GPU, so you can run the Phi Mini GPU exercise model to do the exercise, or you can do it also with the Phi 2, which is the CPU version, and that's also totally fine, but it's going to, with the CPU, it's going to be really much longer. It takes a lot of time than using it with the GPU. So here in our chat playground, what we are going to do first, we're going to start by configuring the voice mode. So we're going to start by enabling and configure the voice mode. So here we have the voice mode that you can turn it on. And from here you can, select which voice do you prefer. So you can here play it to listen to it. And you can select other, for example, Microsoft Zira. And you can select others, depends to what do you prefer. You can also turn on to show avatar, so you have two avatars. Or you can keep it like without an avatar. Once you selected the voice that correspond the most or the more to your style, to what do you prefer, you can turn off the configuration and you can actually start the conversation. So first of all, when I start the conversation, I'm going to start it, and we're going to wait until we have the state you listening to say something or ask question like what is speech recognition and get the answer back, right? So you're going to start session, going to listen, and going to process, and going to speak. That's the stages that we're going to observe in here. So let's start session. What is speech recognition?
Technology that enables computers to identify and process human speech, converting spoken words into text or commands. It involves the use of algorithms and acoustic models to interpret the audio input and match it with known words or phrases. This technology is widely used in virtual assistants, voice-to-text dictation, and voice-activated devices.
What is speech synthesis?
Artificial production of human speech using computers. It converts text into spoken words, typically using a database of recorded human speech samples and algorithms to generate the voice and intonation.
So at any time also you can turn the live caption like you have seen. When I turned the live caption, I was able to see things, to see the text, to hear back, and also to speak. So that's what we expect when we have like kind of conversation where we do text to speech and speech to text. That's it for this demo. In this exercise, we explored the use of speech-to-text and text-to-speech with generative AI models in a simple playground app. Let's get back to class. In this session, we discussed how speech-enabled AI works by combining speech-to-text and text-to-speech, detailing their real-world application and the step-by-step pipelines that transform audio into text and text into natural-sounding speech. Remember that all this material is available for free on the Learning Path, and you can find the full Learning Path at the Microsoft Learn platform. This concludes our session. Thanks for joining us for this session. To continue your learning, we encourage you to watch other videos in this course or search out your next favorite topic on the Microsoft Learn at aka.ms/learn. Happy learning!